Okay, so today we are talking about bisectors. So the first one we're talking about is an angle bisector. And an angle bisector is a ray whose endpoint is the vertex of the angle. So in this picture, angle A, or point A, I should say. A is the vertex of the angle. So you have a ray that starts at angle A, or vertex A, and you draw the ray so that it makes, we'll call this X, since they told us that ray, this should have an arrow over the top, ray AX bisects angle BAC. So that means that it splits it into two equal angles. That's your definition. Splits it into two congruent angles. So this is your angle bisector, and it is bisecting angle BAC. So just like we did with midpoint, we have a couple conclusions that we need to do. For example, based off the markings, I know that angle BAX would have to be congruent to angle XAC, or that could also be written measure of angle, remember little m means measure of, BAX is equal to the measure of angle XAC. And that's all from the definition of angle bisector. We also talked when we did midpoint about the halves idea, right? So if the whole angle BAC was 30, then you would tell me each of those are 15 because it goes down the middle, right? So half of angle BAC would have to be congruent to angle BAX, and half of angle BAC would also have to be congruent to angle CAX. Or we could do the same thing we did before with measure of. The measure of, or I should say, 1/2 the measure of angle BAC equals the measure of angle BAX, and half of the measure of angle BAC is also equal to the measure of CAX. Those are the two main ones, but sometimes with algebra, not with our proofs so much, but with algebra, these two are big for proofs. Algebra-wise, you can use that concept that 2 times the measure of angle BAX would be equal to angle BAC, or if you did 2 times the measure of CAX, you would also get the measure of BAC. And then you got the congruence and all that stuff too. All right, so that gives you your different versions, things you can conclude when you get that definition of bisects. So here's some examples. They give you this information is key, and they tell you these are opposite rays, which means that this is a straight angle. Okay, so that's a straight angle. And KN right here is an angle bisector, and it is bisecting LKM, that red angle. So what that tells you, or what you should know, is that this angle, LKN, is congruent. So based off of this, I know that angle MKN would be congruent to angle NKL. So that should help me. So now I can fill in some information here. So LKM is all of this, and that is 7x minus 5. And then NKM is 3x plus 9. And they want us to find LKM for our goal there. And the fact that it bisects is, again, it's like you're thinking about this number 3. That says that if I double angle MKN, so this is for number 9, MKN, it will equal the measure of MKL. So if I double 3x plus 9, it will equal 7x minus 5. Or if you had filled in 3x plus 9 in the other angle and added them together, you should get the same thing. You would distribute, use your algebra 1 now. So 6x plus 18 equals 7x minus 5. Bring the 6x over, that gives you x. Add that over, you get 23. So x equals 23, but they want us to find LKM. So LKM is really 7 times the 23 we found minus 5. And that should be 156. Final answer. All right, for the other one. So now I'm going to erase my picture and fill in the new information. They still told me that it bisects up in the top. That still holds, so I still know this. But now NKL is 7x minus 9, and JKM over here is x plus 3, and they want me to find JKN. That's my goal, JKN. All right, well, what do I know this time? I know that still this would be 7x minus 9. So I could say if I double my 7x minus 9 and add it to my x plus 3, I know it has to equal 180 degrees because they told me these were opposite, which makes that a straight line. And then again, I would distribute. So 14x minus 18 plus x plus 3 equals 180. Combine my like terms. 15x minus 15 equals 180. Add my 15. 15x equals 195. Divide x equals 13. And again, I'm not looking for x. I'm looking for JKN. And JKN, if I look at my picture, is equal to x plus 3 plus 7x minus 9. Plug in your 13. JKN is equal to 13 plus 3 plus 7 times 13 minus 9. So JKN, sorry, ran out of space here, it's equal to 98 degrees. So there is your angle bisector. All right, next type of bisector, segment bisector. So we're talking about a line, a subset of a line that intersects at a point. So draw a picture of the following. These are line segments over the top. Line segment over the top. So I'm going to give you a minute. You can pause and draw a picture given XY bisects AB. Go ahead. All right, back on. So we have and this is the key, XY is bisecting AB, right? So that means that XY goes through the midpoint of AB, right? That's what that's saying. So if I again, I'm eyeballing the midpoint. I'll call it M, and I'm marking it so someone knows that I understand what midpoint means. And then by definition, then XY has got to go through that midpoint. Doesn't have to look exactly like this, but it has to go through the midpoint. And that does not make XM equal to MY. So try to make that look like they are not equal. All we know is that AB got bisected. In other words, XY went through the midpoint of AB. It does not work both ways. Conclusions. All right, what can I decide based off the definition of bisects? I know that AM is congruent to MB, and we could do measure of and all that stuff. I know same idea with midpoint, right? Half of AB would be congruent to AM, or half of AB will also be congruent to BM. And then more the algebra piece of this, if I double AM, it's going to be congruent to AB, or if I double MB, it's going to be congruent to AB. So those would all be based off the definition of bisects, line bisector. All right, so now we switch this. The difference here is what's being bisected. So now AB goes through midpoint of XY. So this time XY is being bisected. So I got XY. I need to know where the midpoint of XY is. And AB is going to go through the midpoint of that. So something like that. And now your conclusions. You know that XM is congruent to MY in this case. You know that half of XY is congruent to XM, or that half of XY is congruent to MY. Or again, third version, if I double XM, it's going to be congruent to the whole thing, XY. Or if I double MY, it's going to be congruent to the whole thing, XY. Sorry, sloppy congruent. All right, so that would be line bisector. Okay, so knowing the difference and being able to decide based off the vocab which one is being bisected. Final one for today is a perpendicular bisector. So that puts together two words. It puts together bisector, which we just went over, and perpendicular, which we've talked about before. And perpendicular means two lines that form right angle. So they intersect to form a right angle. So if I'm drawing a perpendicular bisector, well, first of all, which one is being bisected? And that is CD that's being bisected. So CD is the segment that's being bisected, which means we got to find its midpoint. And now EF, I can't draw it like I did these because it also has to be perpendicular. So I'm coming through M, not the greatest picture there. Your picture needs to be reasonable, but you also should be marking that box to show that what you were trying to accomplish. So we put the box in the corner, right? At least one box, and we're saying that that is EF. So EF is a perpendicular bisector of CD. Not only does it go through the midpoint of CD, but it also forms a right angle with CD. All right, so what conclusions could we come up with? We can come up with the typical ones we did before. We know that CM is congruent to MD. We know that half of CD is going to be congruent to CM, or half of CD is going to be congruent to MD. We know that if we double CM, this is all because of that bisects piece, it would be congruent to CD. Or if we doubled MD, it would be congruent to CD. We also know from the perpendicular piece that we've got a bunch of right angles. So we know that EMD, angle DMF, angle CMF, and angle EMC are right angles. Please do not say 90 degrees. Okay, we're going with right angles because the definition does not use 90 in it. It uses right angles. So all of these conclusions above would be based off the fact that the definition of perpendicular, that would be your reason, perpendicular bisector. All right, so you've got some practice that's in your online book, and that is review for your test, starting review. And then you've got a Delta 1.7. This says page 42, but it should be your 1.7 problems. And then you've got your Delta 1.7.